Hello and welcome to Chapter 12, Part 2. Today's lecture is going to focus on meat, dairy, and fish. Meat production, as a country's income grows, so generally does the meat consumption of people in that country. And the problem with this, as far as being a sustainable way for humans to trend on the planet, is that it takes a lot more resources to produce meat than it does if you're supporting those humans with a vegetarian diet. So it takes about 20 times more land to produce that meat. And the one that people often don't think about is that it takes a lot more water. Since 7 kilograms of grain is needed to produce each kilogram of meat, and I think that's specifically for cattle, more water and energy are required. So you can see the pictures down here on the right is different. How much water does it take for like fruits and vegetables on the left over to like beef on the far right. And then this, the one on the left is your carbon footprint based on different types of foods that you might consume. This is from your textbook, and you can see that beef is the most water heavy, grain heavy, is basically resource heavy meat to be eating. Lesser amounts are used for fish and chicken. So a CAFO is a term that I've only recently become familiar with. What is a CAFO? It's a concentrated animal feeding operation. What is that? It's basically your big industrialized meat production, your feedlots. This is not going to be your organic farming, your free range farming sorts of meat production. So specifically, it is densely packed. They're usually densely packed and they're fed grain or meal, and it supplies half the world's meat. And it's a lot less, we do it because it's a lot less expensive, a lot less land heavy because you concentrate the animals in a small amount of land, which keeps cost down for consumers of that meat. However, there's an awful lot of issues with CAFOs also. Poor treatment of animals. I'm trying to not show anything too disturbing in this lecture, but you often see pictures and horror stories of the animal treatment that goes on in these feedlots. The other thing is that because you're concentrating all of those animals in a small space, the runoff of the animal waste, which is often very high, like in chicken farms, very high in phosphorus, it can lead to eutrophication and dead zones in local water bodies. The other thing is that often at these feedlots, they feed the animals growth hormones so that they grow bigger, faster. And then if you are then consuming that meat, you are getting those growth hormones also. And so this can affect humans. And another thing that can affect humans is that because you have all those animals living in close quarters, they can be susceptible to infections. So as a preventive measure, many farmers will give the animals a lot of antibiotics. And then that can then lead to antibiotic resistance in your among those bacteria. We're going to be seeing a video on this in class. This is a video or a graphic, and I found it interesting. There must have been some study where they were comparing things to 2030, because when I went researching, you see a lot of these projections as to what it's going to look like in the year 2030. But as far as how much antibiotics are we using on animals, it has gone up hugely in just the last decade or so. So they're projecting out, compared to 2010, what it's going to look like in 2030 if we keep going. And this is just then, what are the concerns with that? As you feed the animals all the antibiotics, there can be antibiotic resistant strains that then come into existence, that evolve as kind of a coevolution thing. And then what happens then is that if humans end up getting infections and get these antibiotic resistant bacteria in them, they can be awfully hard to cure. So this is, I think, a huge concern, that we've been way overusing our antibiotics, and we risk then them losing their effectiveness as these new superbug strains evolve to combat those antibiotics. So, and if you look at just how much antibiotics are we giving animals, a few graphics here kind of point out that. Few pictures, and again, I'm hoping nothing too disturbing, but this is from that same article that I grabbed some of the agriculture pictures from, but a turkey CAFO. Calves. This is in Wisconsin. A cattle farm, and when you look at something like this, the amount of overgrazing and whatnot in order to feed that cattle, you can see there's not a whole lot growing there right now. And then meat processing plants, what does that look like? And as you know, in the pandemic, we've had a lot of outbreaks of coronavirus in these plants because you have a lot of workers working in very close quarters. And here's a dairy farm, and this one is also in Wisconsin. And pigs and cows. And so some of these pictures are kind of hard to look at because it doesn't seem like very ethical treatment of animals. So On the other side of it then, if you feel strongly about these, you can look at free range animals. It tends to be more expensive. It means that the cows, before they're led to slaughter for meat consumption, they're allowed to graze on grass for their entire life cycle. The meat tends to be free of antibiotics and other chemicals, although you should always check the packaging because free range doesn't automatically mean free of antibiotics. And the manure itself acts as a natural fertilizer, so it can be good for the land on which they're grazing too. It does require more land, and it's always, as far as I know, quite a bit more expensive to eat free range meat than to eat CAFO meat. And of course, if you do allow an area to get overgrazed, it can lead to soil erosion and desertification, which we'll be talking about in the second half of chapter 12. You can kind of prevent some of that by rotating your pastures. Seafood, moving along to seafood, fisheries are literally fishing. So it's an area that has a high enough concentration of fish that you can harvest them commercially. And you've seen this. This is a picture, I think, out of Miller. And we talked about overfishing with the tragedy of the commons at the beginning of the year. So here's just a picture of a ship from above. This is up in Alaska. And I'm not going to talk too much about fishing because I think you guys already know a lot about it. So I'm going to move on to something that you may know a lot less about, which is aquaculture. They're basically fish farms. So it's raising and harvesting marine and freshwater fish, algae, et cetera, in underwater cages. So this is actually accounting for a little over 50% of the fish and shellfish that we're consuming, and it's on the rise. So why is it on the rise? What are the advantages? It's efficient. It's a farm, so it only requires a small area of water and requires little fuel. You don't have to go hunting for where the fish are because you're raising them yourself. You have it under, you can also help ensure that success because you're producing the fish, shellfish, et cetera, under controlled feeding, sanitation, and harvesting procedures, mostly in ponds. And then you'll have water flowing through, and to a lesser extent, cages, there's net pens. There's various types that you'll see pictures of as we go through these slides. What are the problems with aquaculture? Because it sounds like a pretty good deal. Whenever you concentrate animals close together like that, their waste can cause eutrophication because it's going to be rich in nutrients. They can also, if you're eating farmed fish, they can put growth hormones also in those fish to make them grow faster and bigger. And this actually happened in the Seattle area and Elliott Bay recently, is that if your fish escape the area, now you have an invasive species problem in the area. And in Seattle, there was, I think it was an Atlantic salmon farm in the Elliott Bay where some of them got out, and now they're worried about them displacing our native Pacific Ocean salmon. And then if you're, this is actually kind of a striking statistic, 3% of freshwater use in the US is used for aquaculture, which again seems quite large. So here's the projections into the future. Where are we now? And this is like as a graphic as of 2010. And if you extend the lines, fishing, as our ocean fish stocks get depleted, we're looking at more and more of our fish supply coming from aquaculture. So what are we doing with this? I didn't give you this information on your notes because this has not happened yet, but it's under talks, is that the US is working towards establishing national standards for aquaculture if it's going to be such a big up and coming thing. So there's new legislation, the Advancing the Quality and Understanding of American Aquaculture. And I like how they put the understanding in there so they can abbreviate the whole law, the Aqua Act. In fact, if you put the act in there, you could add a third A onto that whole thing. So they just introduced this in September and would clarify regulatory system and basically bring some regulation to an industry that really doesn't have it right now in the US. And not just for our national standards, but also looking at the exclusive economic zone, our EEZ, around our country. So this is from one of the senators, Senator Rubio, I know is one of them, and the Senator Wicker said it's the fastest growing food production sector, but the US, we don't really have at this point a comprehensive nationwide system for putting in this in federal waters. So this is from your book, and you can kind of look at this on your own, but there's the advantages and the disadvantages, which I've pretty much have talked about already. And I think I haven't mentioned the dense populations vulnerable to disease, but the high profits is also a big thing on the advantage side. If you can successfully farm fish, then you have you're going to have a good profitable company. So there's land-based aquaculture where you would have these ponds, fish tank on land. And to me, this doesn't seem nearly as economically beneficial or even environmentally beneficial, but it is a thing also. If you're going to have land-based tanks that you're raising the fish, you're going to look at higher costs, higher water usage, which higher energy usage. And then now you're using land also rather than the waters. And so I don't know enough about this to really say that doesn't seem too smart, but it's, that doesn't look super great from where I'm sitting right now. Okay, so just kind of moving on to the final topic, which is a lot of fish suffer from biomagnification of toxins. And so there are safe fish to eat and less safe fish to eat. So on the safe list are salmon, is especially wild caught salmon. Rainbow trout, when it's farmed inland, you're not going to have the PCB issues that you often get from your saltwater fish. Tuna, although not bluefin tuna, which is endangered, and also can have really high levels of some metals too. And then tilapia, if it's farmed, it's very safe in this country. So and then finally, if you're thinking about your choices as an environmental science student and going forth into the world, the carbon footprint of what you eat matters. And these are just kind of some sample carbon footprints. These are going to depend too on where that food is produced and where you're living. So this is not a perfect picture. And so I think that leads into the final slide for this lecture is that one of the best things you can do is, and I think it's a movement that's been growing, is the eat local. So supporting local producers, processors. The less distance your food has to be transported, the fresher it will be, and the less energy cost it will be to bring that food to you. So that is the end of the Chapter 12 lecture, and we'll do parts 3 and 4 after the break.